So we're talking about data storytelling, and this week so far, we've talked a lot about how to tell stories in a compelling way, how to tell stories in an accurate and professional way as opposed to a misleading way. But that begs the question, how exactly do we find the story in the data, right? And depending on your background and your experience, you may already have some experience with this or not. So I want to go through this very critical piece of content. How in the heck do you find the story in the data? I'm going to break this down into a three-step process. In the general kind of abstract case, we're going to dive down into each one of those three individual steps. And then we're going to start working through this will be a collaborative process. We'll start working through a specific data set that's HR attrition. So human resources is trying to investigate attrition. So employees leaving a company. Hey, guess what? This is almost exactly the same kind of problem as customer attrition, which y'all will be working on in the telco data set for your storytelling project. So what we're doing today, I want you to emulate this process and use this three-step process as a guideline for your project, especially if you haven't done a lot of analysis before, right? And that's totally okay. That's totally okay. Wherever you're at, we want to meet you there. So we keep hearing about telling stories with data. Now we have to talk about how to figure out the story that's in the data. You can't just make stuff up. The three-step process that I want you to internalize, and there's lots of sub-steps in here, but keep this at a real high level. Three-step process is step one, define your goal. Articulate why does this project matter? Who benefits? Why should anybody care? What is your target variable? What are you trying to actually measure? What's the story? If your story is customers are leaving, we would need to figure out why. Then whether or not a customer left is your target variable, right? That's a very important term, target variable. And then also any initial hypotheses that you have. And we'll talk about what initial hypotheses look like, where you can get them, and how to start working with that. So you're going to see that next to each step, I have a documentation step. Step one, define your goal, why it matters, define your target variable, any initial hypotheses, then write them down, either in a notebook, like a project notebook, or in a README file, or in a document that you share with your team. Right? Step two is to get to know the data that you have. Your goal here is a 10,000-foot view of what your data looks like in the aggregate before diving into comparing subgroups versus the population or subgroups with each other. It's really critical. Like, okay, if customers are leaving or if employees are leaving, like what's the overall rate? And then we can look into subgroups and compare their rate to the population. Again, as you get to know your data, what columns do you have? What do they represent? Does some of this data come from a survey? Is some of this data objective, right? Write down what you learn, write down what you discover. And then when you're ready to start analyzing that data, the third thing that you're going to do is answer your initial hypotheses questions with visuals and statistics. And I realize we haven't moved into the statistics module yet, so we don't have an entire full toolbox for this project. But you do have the ability to compare subgroups to the population, compare subgroups to each other, and that right there makes for a good analysis. I see a hand up. Was that Arsene? Go ahead.
My question is, are we going to talk about tools that we can, appropriate tools to have a bird's eye view?
We're going to talk about tools. Yeah, use any tool you got to get a bird's eye view, whether if that tool is Python, a spreadsheet, Tableau, whatever. This is a general process that you'll use regardless of tool. Does that help, Arsene?
Oh, what I meant is, like, are we going to talk about specific tools that are more likely to give you a bird's eye view, or that is just depending on us? We just choose.
Don't overcomplicate it. You look at your data, you think about your data, you figure out what each column means. There's not a magic tool for that. There's not a magic tool for thinking. Yeah. And for the purpose of this demo, we will be collaborating on a specific data set and discussing how to peel this apart and figure out what stories might be in here. This is really it. As you answer your initial hypotheses with visuals and statistics, those are your takeaways, right? Businesses don't need fancy pants machine learning to predict things if they don't even know what's going on right now or yesterday or last year, right? So we need to get into our basics. So step one, we talked about defining your goal. Weird. All right. Excuse me, this thing's being weird. All right, that should be better. So the step one, before you start doing any work, you've got to define what you're after. What's the goal? What's the impact? Who benefits? Why should anybody care about this project? Because if nobody cares about the project, you're not going to get the budget to work on it, right? Analytical talent is expensive. Labor is expensive. So when an outfit wants to understand something, before you get started, before you start slinging any code, figure out, is this affecting the bottom line? Is this a pet project for a VP? What's the deal? Like, how important is this? And what happens if we don't do anything? The number one thing you're going to do here is write down lots of notes, type them, handwrite them, whatever you got to do to answer the question. What's the goal? Who cares? Who benefits? What happens if you don't do anything? What's the best possible outcome, right? Telco customer churn, that data set best possible outcome is you keep customers and make more money, right? What's the worst possible outcome? You don't discover why people are leaving that company, and then they keep doing it, right? So what exactly are you seeking to understand? These are some, but not all of the questions that you'll ask at this planning stage. You'll find that what I'm talking about with this three-step process mirrors the data science pipeline, only without any machine learning. That's it. That's the only thing that I'm doing differently in this pipeline that I'm walking you through. This isn't something new and crazy and different. This is plan, acquire, prepare, explore, deliver. We talked about the delivery, but how do we figure out the story? That's what we're talking about right now. So in that planning, define your target variable, right? In the telco churn, your target variable is whether or not the company lost that customer. Each individual row in that data set represents an individual customer or a household. And you have historic data if that customer stayed or left. You also have other information like what they were being charged, what extras they were purchasing. So define that target variable. Hopefully you do have that target variable in your data set and it exists. And then define your initial hypotheses. Literally write them down. Anybody seen the television show Mythbusters before? They blow a lot of stuff up, don't they? I'm going to quote, I think it was Adam Savage on that one. The difference between science and f***ing around is writing it down. So that's what makes you a professional. That's what makes you the scientist and data scientist is writing things down, forming a hypothesis, writing it down, testing that hypothesis. Because if you're not doing that, you're just screwing around. And this isn't the screwing around program. This is the data science program, right? So write those initial hypotheses down. Okay, this begs the question, how do you get started with initial hypotheses? I'm going to show you a little comic first. Really, all it takes is starting to think about the problem, is what this comic is trying to drive home, right? Literally write down those hypotheses. Are your stakeholders, is your supervisor or your supervisor, are they trying to confirm or deny something? What are they trying to understand? Maybe stakeholders don't already have a hypothesis. They just want to know what's going on, right? Do you have any initial hunches? Your stakeholders have hunches that you can confirm or deny. Is there anything that you kind of take as a given in the industry that you want to test and see if that's the case at your outfit, right? What if customer attrition, customer churn is like 10% across the industry? Well, write that down and then figure out what's our churn rate. And based on the columns you have, so like slow down, take a look at your columns before you start slinging any code or doing any other analysis. Think about what columns you have, and do you see anything that you know you need to look at? Right, if we've got the telco churn data, we know how long customers have been with the company. We also know how much they're paying. So I'm thinking people leave when they pay more for service. So I'd write that down as an initial hypothesis, right? And then you can confirm or deny that analytically. And that way you're not just messing around. Your initial hypotheses, you don't need to make 40 of them or 30 of them or 20 of them or 10 of them, just a handful to get started. The most important ones will be the burning questions that the business has already, or the burning questions and curiosities that you have already. Right? And as soon as you have some initial hypotheses, it could be as little as 1, could be 2, 3, 5. Keep it low. Keep them where you can count them on your hands, on your fingers. Once you've got your initial hypotheses down, define this magic term. We're going to introduce this magic term called a minimum viable product. Now let's peel apart those 3 words. Minimum means not every bell and whistle. Viable means it's actually useful. And product means it's not some pie in the sky, it actually exists. So your minimum viable products are defining exactly how many of your initial hypotheses will be enough to justify the time you spend. Because you don't always have 9 months to work on a data set, 9 weeks. You might not even have 9 days. Sometimes you don't have 9 hours to work on a data set. So define this early before you get lost in the data. And define, how do you know when you're done? I mean, maybe the question is as simple as, why is the telco company losing customers? And if your initial hypothesis is they're charged more, well, by gum, you can dive in and answer that question and you've got something to show, right? That's not the whole story, but it's part of the story. And how do you know when you've got something to deliver? Sometimes I'm here to tell you, you might not find something. You might not find a smoking gun. You might not find a silver bullet. Being able to confidently explain, I dug into this very deeply. I found no relationship. That's still a takeaway. It's like Thomas Edison inventing the light bulb. He found 1,000 ways that didn't work, right? And then if something in your process of going after that MVP, think of your MVP as your first draft. That's all it is, first draft. Not a perfect intro, but a beginning, a middle, and an end. That's an MVP for a story, right? In the beginning, there was a boy living on Tatooine with his aunt and uncle. And then his aunt and uncle are killed because an empire are looking for some androids, right? Some droids. And then he joins the resistance and right? So beginning, middle, end, regardless of the depth, you can keep it shallow for the MVP, because the second draft is the process of making it look like you knew what you were doing the whole time. That's what a second draft gives you. It gives you the ability to look good. The MVP just shows that you've got something to show. If something's really, really interesting to you, but it's not part of your initial hypotheses, just write it down, add it as a backlog item in your Trello, come back to it in your second draft, but don't chase every rabbit. Jen?
Just on that note, because I feel like there's going to be so many different rabbits.
Oh yeah, for sure.
So my question, I guess there, and I'm sure it's situationally based. When do you bring it into scope? Is it when the business itself is looking at that target area? Does that make sense? Or are you actually like organizing yourself so that you have time to look at those rabbit holes?
You might not be able to chase everything. You certainly won't be able to chase everything. I'd say second draft is when you can start really chasing another rabbit or two. But depending on if that second draft is trying to get that MVP to polished out the door before your vice president takes the airplane out of town, you might not have that chance. That's something that I think everybody struggles with, is we want to tell them everything we found because we find really cool stuff. If you do go on a side quest, you might discover something nobody else has seen. So there might be high value, but there's also high risk of derailing yourself. So I'd stay on target as my guidance here. So initial hypotheses, sit down and think about it. What could be going on? If you were a customer of the telco data set, under what conditions would you leave? Price, service, internet speed? Like, we don't have all of the data. We don't have internet speeds for all of the customers. But with the data that you have, put yourself in the customer's shoes or put yourself in the subject's shoes, and that can help you generate some hypotheses. Yeah, Jason. Yeah, yeah. Totally. Bert?
So in that situation, just because you said, like as far as like speed and stuff, you ever use other data sets from other companies? Like for instance, like let's say we're working for Comcast or something, and all of a sudden a fiber network came into that area. You use that data set as well to back up your statements.
I mean, if you can get it legally. What you might want to do, and what I'm hearing there is how to be resourceful in answering these questions. You might look at, if we're investigating customer churn for telco, let's pull up customer churn for the industry as a whole. That's not a super secret, right? Or like, and this begs the question, why is churn so important? We're going to do a whole project on why customers are leaving telco. Companies can find new customers, right? But the big challenge is finding a new customer is more expensive than keeping one in just about any industry. And then telecommunications, at least industry-wide, the cost of acquisition is like $300 or $400 per customer. Just did a little search on that last week and looked for industry cost of acquiring a customer in telecommunications, internet service provider customer cost. So a little bit more on that MVP. Now, this diagram is going to show something with wheels, but our MVP is insight and takeaways that our stakeholders can use to improve their decision-making. So they can get in front of the board and say, hey, I made a data-driven decision. They can check that box, right? Now consider, it's a lot of work to engineer 5 different products down here, right? Versus 1, but notice that all of these products on the bottom, the goal is you move forward, not on foot. Our takeaways and our insights are our minimum viable product. And the example here is your stakeholders won't care if your data acquisition and data preparation code is object-oriented and it's in modules and it's super squeaky clean and you have a cached version locally. They don't care. Did you find anything? No, I'm still cleaning the data. Right? Clean it till it's good enough so you don't have a type error trying to do arithmetic on a column of $ strings, right? But the part where you make a super squeaky clean acquisition script, it's modular, you've had code review out the wazoo. A perfect beginning of the story doesn't get to the middle and the ending, right? That's what we're going for. Again, in the beginning, then in the middle, and then the end. Beginning, middle, end. It works for stories, works for analysis. So that's what this diagram is trying to show. Shoot for insights, not perfection, because perfect is the enemy of the done. Cool. So let's jam a little bit on this step 1 in the general case. Any questions, or what questions are coming up for y'all? What questions, comments, concerns, thoughts, experience in a past work life? Yeah, Fred.
Kind of a specific question, but when you're doing a market research to answer the question,
Mhm.
and you're taking a look at kind of what's the industry churn rate,
Yeah.
are you trying to get data sets or just good enough to kind of find?
You're, yeah,
AT&T's churn rate, step that, or you have to confirm that?
you're probably not going to get your hands on data sets from your competitors. That would be shocking.
So,
Yeah, they want to control that data. Like otherwise they wouldn't have passwords for their databases, right? What you'll probably find is industry-wide aggregate statistics from things like industry interest groups or even regulators, right? Or Bureau of Labor Statistics or aggregating bodies like that, right? Bureau of Labor Statistics or Chamber of Commerce for local stuff may have descriptive stats for local industry, but yeah, AT&T is not going to share their data set. And we're not going to get one from Verizon, right? So that's kind of a challenge. So that's something we have to face. Yeah. Yeah. What else? Other thoughts, comments, questions? Yeah, David.
I mean, like I said, there would be a way to tell, okay, someone who left AT&T and went to another company. Like, by those statistics, would you be able to tell?
How could we have that information? Do you tell anybody when you change carriers? Yeah.
It would still tell, it wouldn't give it that number.
No, and I mean, despite all of us carrying tracking devices in our pocket, the amount of information that companies know about us is actually kind of low in a lot of ways. Yeah. When you leave AT&T, they don't necessarily know where you go, right? And how would they unless they just actually spied on you, right? Or there was collusion between the companies, which is illegal.
One question I had, I can't remember if you covered this or not, is like kind of the ethical place of where you're grabbing your data. So
Yeah.
you're doing comparisons.
Sure.
Is there a good rule of thumb? Because I know like college, like they're like, they stay with Wikipedia, right? They give like those kind of analogies.
Sure.
Is there something similar to that when it comes to grabbing data?
I'd say after however, like 20 years of Wikipedia being established, it is a trustable source at this point. And if you want to dig deeper, people cite their sources. Yeah. But ethics. So let's say you're Panasonic, you work for Panasonic and you find out that there was a hack on a competitor, Sony. It would be unethical to go and find that hacked data on, Mega Upload or some torrent site or whatever. So my professional advice is don't use hacked data from a competitor.
Or even like, I guess one thing I'm thinking of is like, if you're going to forums and someone's like, oh, maybe like look at this data set, and you're like, oh my gosh, that's something I'm looking for. It's like, I would say probably do more research to see where those are.
Yeah. Dive a little deeper, right? Because our telco data set isn't from Verizon. Yeah.
Say if you're looking at Netflix and all that.
Yeah.
Stock price is going down for a while. Is it going down because they have more competition, or is it just going down because their product is not as good?
Yeah. And stocks are really challenging because there's a lot of different reasons. A lot of different reasons for stock prices. So we'll stay a little simple with figuring out why people are leaving a company, right? And churn rate might have something to do with stock price. Yeah.
How would you know where to find?
Let's see, acquisition through means not agreed upon by your competitor is corporate espionage, which is illegal. Yep. I mean, that doesn't stop people from talking shop, right? But you're not going to like go to Google data sets and find your competitor's data. How do you know where to find hacked data? So that's a larger question, V. Cool. Yeah, Bert.
So I have a question, are you like in a real world situation,
Yeah.
especially talking about Netflix?
Yeah.
Can you just, like, can we use environmental data as far as like, okay, we're just getting out of a pandemic, people are going back into work,
Yeah.
they're being entertained less, so it's like, are we able to use that as well?
Are you kidding? Yeah, of course you're able to, if it makes sense, right? I mean, the data science police are not going to tell you, well, don't use relevant contextual data. Everything should be contextualized as much as you can. Yeah.
Something like that doesn't necessarily sound like you have to say. You just assume that it probably can't. That's the
It's a
assumption.
possibility. Yeah.
Sounds like I'll just write down.
There, Fred's hitting it. You write it down. You write it down. And if you find that you've written something down and you can't find data anywhere for it, leave it written down and say, I couldn't find data anywhere to support or refute this. Yeah. Jason, and then Lincoln. Oh yeah, all the time. All the time. Every app that's tracking you makes more money off of selling your data than whatever the $2.99 download was. Yeah. And if a product's free, you're the product. Lincoln?
I just wanted to ask, like, are we gonna do some, let's say, ethics kind of class in terms of like, because I think sometimes I feel like ethics varies throughout like different industries. You know what I mean? Because
Yeah, Goldman Sachs has different ethics than the Red Cross. Yeah.
You know, yeah, I was thinking like finance has like
Sure.
different ethics when it comes to like even
Yeah.
exactly the Red Cross. So I'm gonna learn like specifically based on like data, like say acquisition and stuff like that.
Keep it real simple.
Yeah.
If you would feel ashamed telling your grandma about it, it's not right.
I just feel like,
Well, that's good. That's good. Cool.
Stephen's question.
Yes, go ahead, Stephen. Yeah.
Assuming that like if you roll like say a web scraper and like the websites that scraper like okay with it.
Yeah.
But that's not sort of like pick up data that isn't actually going to do that out, even though like for whatever like let's say it's not exactly what the web scraper but like for API.
Yeah. They didn't want it on Twitter. They shouldn't have put it on Twitter.
Yeah, it sounds like is that like an ethical gray area or
No, as long as you're abiding by
because it's like
the terms and conditions. Yeah. And the terms and conditions for scraping is in a file called robots.txt. I mean, scraping is how Google made a search engine. It's how Yahoo made a search engine, right? Yeah. Don't get too bogged down in the details, but do the right thing, right? Do the right thing right now. Keep it simple. We're going to work on a telco project. Write down your hypotheses, write down what a minimum viable product looks like. We'll do a deeper dive on ethics a little bit later. Cool. We'll have a deeper dive also on MVPs and strategies for MVPs. For right now, keep it really simple. Here's my guidance. So once you've done some work to define what you're after, why the project matters, who cares, who benefits, what success looks like, what done looks like, then it's time to start getting to know your data at a very high level. To me, my mental image of getting to know your data, summarizing it at a high level, is dumping out all your Legos and seeing what you have, seeing what pieces you have. Now, I'm going to advise you take lots of written and typed notes as you move through these steps, write things down, hunt down a data dictionary that explains what each column of your data is or represents. That's what a data dictionary is. Sometimes you don't have them. We didn't have a data dictionary for the employees data set, did we? We just had self-evident column names like title, department name, employee number, department number, department manager table, right? Sometimes you may have to be, in order to move forward, you may have to make a data dictionary for the data set to begin with. right? In telco, it's going to be pretty broken down. Like tenure is tenure in months, total charges is lifetime charges, monthly charges is charges per month currently, et cetera, right? Sometimes, depending on the complexity of your problem, getting definitions for your columns may mean talking to people at the outfit. It may mean taking somebody from accounting out to coffee and saying, what are these columns here in this report? Jane, my supervisor, Jane, asked me to look into this. You've been here for years. Like, I'm playing catch up here. What do these represent?
The absence of the data dictionary, people have all these people and ask what it is. And we can write a data dictionary.
Yeah, write it down. Write it down. All it is a list. Really, it's not that complex, but your future self will thank you. Yeah, Fred, did you have a question?
I was just gonna ask what the data dictionary actually looks like, maybe the title of your columns or something like that.
No, it looks like, let's pull up telco data set. This is a pretty common data set for educational purposes. Y'all have a copy of this. We have a more fleshed out version in the database. And when you go into this, they will explain, let's see. Telco customer churn data dictionary. This is kind of lazy. This isn't every single column, but customers who left within the last month, services they signed up for, so phone, multiple lines, internet. Notice each of those are columns. Customer charges, demographic info, and then it lists out the demographic information. Sometimes it's that simple. Other times it's column by column, what each column means. And you shouldn't have to explain, an age column or a monthly charges column, but it helps to explain everything.
I think you can write it, so if we, I know like advantage, we can call info, or show dot, and then something, same kind of thing.
No, it's English, plain English. Just like we saw right here. This isn't listing out every column individually, but demographic info, gender, age range, if they have partners or dependents, those are each columns. Okay.
We're writing it ourselves, like we're writing it ourselves. Would we be able to write documentation that we can then call later with that kind of method? Does that make sense? Like that has to be tied to the database, so that table itself, the database.
You could, yeah. Yeah, my advice is write it in English first, yeah. You may remember the show doc argument from the Pi data set. All that is a print statement of English. Somebody wrote up a bunch of text and then it's a print statement underneath that prints the text. Yeah. So getting to know your data at a high level, what I mean by this is take a look at it, take a peek at it. What columns do you have? What does each row represent? So let's talk about that. What does each row represent specifically? A customer? A household? What is that? And sometimes taking a look at the columns kind of jogs your creativity. Oh, there's income in this, or there's a cost in this. What's the relationship between cost and attrition, right? And then determine if there's any columns that you need to clean beforehand and do it, right? Do you have a column that's strings with dollar signs, with commas? No, clean it, turn it into a float, right? We'll have more guidance on handling missing data a little bit later. Don't get hung up on it, but do you ignore the entire row? Do you fill in values for the missing data? We'll cover this later, but this is a thing to ask yourself as you get to know the data, right? If 80% of the rows are, or 80% of the columns are missing, do we keep that row? Maybe, maybe not, most likely not. And some other ways to get to know the data at a high level. Output the distribution of your target variable. Output distributions of other interesting variables. So that means histograms. That means dot value counts. That means dot hist. on a data frame or a series, right? And there's no substitute. Like if you just start slinging a bunch of code before you read the columns and think about them, just sit and think about them, you're going to have a bad time. Notice at this high level, we're not yet comparing A to B. We're not comparing total charges to churn at this point. We're looking at the distribution of total charges, the distribution of churn. Does that make sense? This is all kind of part of the, if we were to compare my 3-step analysis here to the data science pipeline, this would be in the planning, acquisition, and preparation stage. Right? Once you start comparing X to Y to Z, then you're getting into data exploration. So if we were to model any of this data, which we're not right now, but if we were to model any of this, we would split this up into a test set, a training set, and a validate set. We'll talk about that later. So we're trying to figure out the story because you can't tell the story until you figure out the story. So we start by getting to know the raw data. Then once we start diving into things, we will filter. And when I say filtering here, I mean, now that we know the overall churn, and let's look at just the customers who stayed. How are those customers who stayed different than the customers who left? What's significant? What columns are significant there? So you're comparing subgroups to the population, hashtag statistics, right? And you're comparing subgroups to subgroups, and you're using statistics and you're using visuals at this point. We won't do hypothesis testing. So there's statistics that can give you confidence and not just averages and things like that. And we'll talk about hypothesis testing after this, like after storytelling. But once you've got some visuals and some descriptive stats that tell you what the heck's going on, then you've discovered your story. Your story is your questions from your initial hypotheses and the answers to your initial hypotheses. That's it. Then you use everything that y'all have been talking about this week already to tell that story in a compelling way, to tell that story in a visually digestible way, so you can get your point across to your audience. Right.
Roughly as far as like the story, I know it's supposed to represent results. How long should these results be? Should it be very simple as far as like this is the data, or let me go into a full 30-minute story?
The question was, how deep do you need to get into the story? 30 minutes, 5 minutes, what's the best practice? You've got to be able to know your data and your answers to your initial hypotheses so well that you can explain it on an elevator ride. We call that the elevator pitch. You're on an elevator with a VP. The VP says, "Oh, I'm sorry, I couldn't make it to your presentation. I got to fly back to the home office." You're on the elevator with them. Well, I'll tell you what I found. Churn customers were different than staying customers in this way, and this way. Let's follow up. If you can't explain it on an elevator, you don't know it. And yes, that is challenging when there's complicated intricacies going on, but hit the high level. So there's a couple of different audiences. There's the elevator pitch. That's a real thing. It's not something we made up at Coda. The elevator pitch. And on any kind of a presentation, 5 minutes, people start tuning out. Your data team may be very interested in the 10-minute, 20-minute presentation, if you're lucky, but you got to get to the point. So I'll get to the point. Step 3 is once you've created your initial hypotheses, you define what done looks like. You know what the MVP looks like. Now you've got to deliver. Step 3 is you answer your initial hypotheses with visuals and statistics. And let's start at the beginning. Always write down your takeaways. As you discover things, write them down because you will forget them. We're all human, right? We can only keep so much going on in our head at one time. Oh, I'm going to remember this for later. Then you get the text message about the dog, right? Or whatever. So write things down. Writing is words that stay. It's really cool. It's better than thinking you're a super person, that you're Superman or Superwoman, can remember everything. But that's just going to set you up for failure, right? Use your visuals, your descriptive stats, and any inferential stats to answer your hypotheses. Answer one at a time. Visualize and get stats on the population versus your subgroup, subgroup versus subgroup. Right? If you're looking at telco data, start with the larger subgroups first, instead of women customers who are over 65 who only have fiber cable. Let's just start with comparing gender to gender. Let's compare senior citizen to non-senior citizen first, before you get into like this teeny tiny little slice. Does that make sense? Yeah, okay. So we're comparing subgroups to subgroups and subgroups back to the population. And again, focus on getting the biggest bang for your buck, for your time, rather than counting the toenails on an ant, right? Women customers over 65 who don't have support contracts but do have fiber, it's too much. Compare larger subgroups first, unless you are specifically tasked with this one specific little sliver, right? In the little visual here, everything that we've done so far with visuals is descriptive stats. The next module in the course after storytelling is inferential statistics. This gives us some confidence in what we're seeing, not just comparing averages, but how much faith you should have in things. And what we're really doing here is exploring and explaining relationships between our target variable. Again, target variable is whatever you are interested in. If you're analyzing churn on telco, it's the churn column. If you're analyzing rainfall numbers for a given area, and you've got other information like cloud cover, et cetera, then your target variable is rainfall. Cool. So what I want to do is get into a more concrete application of these 3 steps with a different data set than y'all are going to be working on. It's basically the same shape. It's an attrition problem with employees instead of an attrition problem with customers. So to do this, I want I'll introduce you to the data set. And then as a collective endeavor, I want us to write down some initial hypotheses. And then as a collective endeavor, I want us to talk about why this might matter. We've been going at it a little while. Do y'all want to take a short break? Get the blood flowing? All right, let's do 10 minutes exactly, 10 minutes sharp, and we'll get our hands on some real data.
You're still muted.
So what we're going to do now is demonstrate and exemplify the three steps we talked about in a general form. We're going to make them concrete, so you have a guideline, a guidebook on how to find a story in your data set and how to build it out. So let's do some of this together. So we're going to do a concrete specific case of all of these 3 stages. And for review, these stages are mirroring the planning, acquisition, preparation, and exploration steps of the data science pipeline. The only thing we're not doing is doing machine learning. And the storytelling component of this, we will make that story out of the story we discover, right? So step 1 is to define our goal, why it matters, and target variable, identify the target variable, and state initial hypotheses. So this is, let's dig into this a bit. And as we move through this, we're going to have a collaborative discussion. So in step 1, I'm going to tell you that our data set is attrition, at least for this demonstration, because I'm not going to do the project for you, right? In this data set, it's a very similar kind of problem. We have demographic information like age, and we have gender in here. And we also have other information like educational level, what department people work in, how often they travel, rarely, frequently, ever, how long their commute is. There's some self-reported data, some survey data like employee satisfaction. Hourly rate is how much that individual is making an hour. Right? Marital status, some more demographic information, monthly income, percent salary improvement since their last raise. That might be interesting. Number of hours they work, tenure at the company, years with their current manager, et cetera. There's a lot in here. We're not going to be able to look at everything in this demonstration. But let's talk about this. So if our problem, HR comes to us or manager shows up and says, HR gave us this data and wants to know why people are leaving. You're not always going to get a business question that maps one-to-one to a statistical test, right, or a visual. So your manager shows up with a data set, says, hey, yeah, HR has been hearing cool stuff about the data wizards over in our department. Now they want us to look into something. So why are people leaving? That's what our goal is. So, or that's what the request is. So what is our goal? This is, let's write this out together. If we know that attrition is happening and HR is interested in it, what would our goal be as an analyst? Yeah. What are the drivers of attrition? What are the drivers of attrition? Like where does attrition show up? Do we have a certain demographic information where those customers are really sticky? They just stick around no matter what we do to their price? Or is there something else going on? What are the drivers of attrition? Why does attrition matter to a company or to individuals? I don't know. They just told me to look into it. No, like what's the motivation? Why does this matter?
Money to hire and retrain new people.
Yeah. Yeah. And if you don't know the answer to these questions, hit a search engine. Why is attrition important for companies? It can decrease labor costs without incorporating staff departures. Yeah, do a little digging. Why does attrition matter? I did some research this morning. A quick search here showed that anywhere between that replacing an employee can cost between 50% up to 200% of their salary, depending on the hire, because you've got to take time to hire. You may have to have a more competitive rate out in the marketplace. So yeah, this is directly related to the company's well-being.
Competition now, potentially.
Yeah. Losing skilled employees to the competition. I mean, if you know that individual was not the best at their job, maybe you're happy they're at the competition, but in aggregate, they're taking their knowledge, right? Why else does attrition matter? Why would you care if you were on this team?
Productivity.
Productivity?
Somebody else.
Yeah. Ooh, productivity. Current team picking up the slack for lost employees. Yeah, that's a morale issue, right? Yeah, I don't, at the end of the day, I'm not being like, oh man, all these people left. We're not productive. No, I'm kind of thinking about my own scenario, right?
That's,
Right.
I don't know the exact statistic, but there is snowball effect. First league, everybody else sucks. They get something better, and everybody else starts coming out, well, maybe I can think of something better.
Yeah. And this can happen with not just employees, this can happen with customers, right? As well. I think that kind of talks about why that matters, right? Yeah, there could be some more stuff here. Maybe maybe HR's gets a bonus if they keep people. That's why they're asking you to look into this, right? Maybe the VP of HR gets a bonus if they bring down attrition. I mean, how do you find that one out? I mean, conversing with people. That's a coffee and chat thing. That's a coffee and all source intel issue, right? Like, just don't stalk people. Have coffee with them, talk shop, right? So attrition matters. What's our target variable?
Attrition over a certain time period.
Yeah, attrition itself is our target variable. In our data frame here that we'll pull up, we have a yes or no for if that individual employee left or not. Just like you will in the telco data set, you'll actually know that. So attrition itself. And what are some interesting variables? I like to ask this question as well. What are some interesting variables? And I'll give you a look at them. We have demographics, we have department, we have some survey data that's like, there's job involvement rate, job satisfaction. Should we believe those surveys? We've been doing them. Should we believe them? I don't know. There's income here, how much they travel. So what are some other interesting variables that you think might drive attrition? And this is another way of saying initial hypotheses, right? Yeah, I see some hands. I don't remember who was first. Greg?
Let's say probably years since last promotion.
Years since last promotion. Yeah. What else? Bert?
Overtime.
Overtime?
They match the attrition. Yes or no?
Yeah, so that's asking the question, what's the relationship between overtime and attrition? Which is, and this one is, what's the relationship between years since last promotion and attrition? If we pull up all the attrition, yes, and they have like 10 years, then those individuals are being hosed, right? Overtime, ¿qué más? What else is on y'all's mind? Somebody remotely.
Company culture.
Say that again?
Company culture, it may not be like a numerical variable, but we can find that out.
Yeah, company culture, we have a couple of things in here that there's not like a culture number, but we see a job satisfaction, relationship satisfaction. So that's ranking a relationship with your manager, not like your home life. Work-life balance is a survey. So we have some self-reported data in here. There's some concrete things like stock options or total number of working years in the industry. But some of this is self-reported, like job satisfaction, relationship satisfaction. So like job satisfaction.
Yeah, that's what I meant when I said we can find out, because
Yeah. That's their monthly take home.
I see monthly income, then it's monthly break.
I don't know. We'd have to investigate that a little further.
But if you check all the bottom, it's like the years since last promotion or something like that.
Yeah.
Yeah, it's like,
I like that one. Years in current role. Yeah, I mean, we could tell a lot of stories here. Years since last promotion, years in role. Maybe they're feeling stagnated. How about income?
competition.
How about their monthly income or travel. Bert?
I'll just say, marital status, because usually that was a big one.
Yeah. Or other demographic info. Yeah. I mean, right now we have 6 hypotheses that there's some relationship, and our hypothesis could be, our initial hypothesis doesn't have to be a scientific hypothesis. It could be just as simple as, what's the relationship between monthly income and attrition? The obvious hypothesis is people leave when they're not compensated, right? Or what's that?
It's a number of companies working with like 8 to 1.
Yeah,
So
yeah.
you jump around the job.
Yeah. It could be all sorts of stuff. So we have plenty here. And we have some initial hypotheses. We might say more years in the role mean they're going to churn, more years since last promotion mean they're going to churn. So we need to start diving into this stuff. Let's answer this other question. What would a minimally viable product look like? What would a first draft look like? Remember, MVP is a first draft. A second draft makes it look like you knew what you're doing all along. Right?
So I think you want to initially add a more specific question, like what target rate churn with initial analysis on variables.
Yeah. What's the biggest story? We may find a relationship with years since last promotion. We may find an even more powerful story with job satisfaction self-reported number, right? What's the biggest story? Or 2? Yeah. When I look at this, I'm thinking, okay, we have survey. I'm going to add one. In the spirit of discussion, I'll add my own thoughts here. We have survey data about job satisfaction and work-life balance. Should we believe those surveys? A lot of people lie on surveys. A lot of people tell the truth on surveys too, but in this data set, that might be a leading indicator. We might know if somebody's about to leave the company if they leave bad reviews, and if they say their job satisfaction is low, and if they say that their relationship with their manager is poor, and if they say that their work-life balance is poor, right? Cool, cool.
Pete has a question.
Yeah, go for it.
I was gonna say, can you specify like what the product actually is in this case? Because like when you say what's the biggest story or 2, that to me isn't a discrete product. So are you saying get an answer to what the biggest story or 2 is, or in graphical form, or just a sentence? You know what I mean?
Get an answer to the biggest story or 2, maybe 3. Our deliverable here. Y'all don't have a deliverable on this HR attrition data set. You do have a deliverable on telco customer churn. What is your deliverable? It's going to be a slideshow and an analysis and showing some of your work, right? So we'll say defining a deliverable. Could be as simple as an email with a few sentences, recommendations. Could be a slideshow. Could be an ML model that we deliver to the engineering team to deploy live. There's a lot of different deliverables. For the purpose of what we're doing in this exercise today, all I want to do is answer some of our initial hypotheses with some charts and visuals and maybe some descriptive stats. to give us the raw material for telling a data storytelling, right? Yeah, great comment and question, Kate. Like defining your deliverable is part of your MVP. You don't have an MVP unless you're delivering something, right? The P is for product. You're delivering some product. What is that? Is it a 7-sentence email? It could be that simple. Why are employees leaving? X, Y, Z. Here's what I found. You don't always have time for a presentation and a slideshow and follow-up questions, right? Cool. I think we've got a pretty good step one here. How about y'all? If you follow what we've done and you emulate what we've done and you do this on the telco data set, you're gonna be off to a good start. Notice we're not slinging any code yet.
This is something that is gonna be written for ourselves, right? Like, for instance, maybe on paper or something, this is something that we'll keep.
It turns into raw material. So the question is what you write down for step one, is that just for us? And the answer is no. It is your raw material for what you deliver, right? A lot of times you will copy and paste your initial hypotheses from your planning document into a final document that explains what's going on. And sometimes not. Yeah. Managed to get pretty far with no code other than just enough code to look at the columns. And if we don't know what the job satisfaction, if low is good or if high is good, IBM, HR analytics, attrition, I'll put a link to source your data, right? Always source your data. As we look at this, the education level starts at 1, goes up to doctorate level. Environment satisfaction, low to high. Job involvement, low to high. These survey questions, job satisfaction, low to high. Performance rating, low to high. Work-life balance, low to high. For all of those kind of survey questions. And then some of the other columns like business travel or department are fairly self-evident. Okay. So what we're going to do here is move into step 2, where we get to know the data at a high level. And this means histograms and value counts. Regardless of if you're using Python or spreadsheets or Tableau or Power BI or R or Scala or any number of tool out there, just give me a frequency diagram of value counts. Of our target variable and variables of interest.
Andrew has a question.
Yeah, go ahead.
Hey, Ryan, I know that today, like this is something specific, and I'm curious about like the whole data science pipeline that we talked about before.
Yeah.
Before we do step 2, if I remember correctly, we're going to split the data up. So we're only examining that set of data, not the test or validate data, right? We want to separate it out so that we can only have a specific snapshot of like stuff that we can test our machine learning model on later on, right?
Yep. I would say that my step 2 here is part of it's part of the preparation a little bit, just getting to know histograms and value counts. I'm not looking at 2 variables at a time. So I'd say a general guideline. If you're looking at how X and Y move together, if you're doing anything with multiple variables, we need to operate on the train data set. For this, we're not going to do any modeling in this project, so we're not going to do any splitting. But my advice here is if you're doing any ML or have any chance of doing ML, split the data before exploring. And exploring is looking at multiple variables together, not just a histogram of the target. Did that answer your question, Andrew?
Yes, thank you very much.
So I'd say, yeah, value counts, histogram, fair game on your target, couple of variables of interest, but we're not going to plot out X versus Y versus Z until we've split the data. And I thought I saw another question. Yeah, Jules, go ahead.
Everything. Okay, so I'm just curious about this. So when there's not like a very clear correlation, right? So what are you all defining as correlation? Because if it's like Pearson, for example, on the fertility, it never reached above 0.70, nothing did, except like Catholicism and is Catholic, depending on what you put that as. So how are we supposed, like, are you gonna tell us how we're supposed to define whether something is correlated or not? So that we know how to properly do this? Does that make sense?
Yeah. So I'll define correlation as not just any relationship between data, but correlation as a linear or a curvilinear relationship between two numeric values. Your R value itself of like 0.7, that's pretty good in the real world. That's pretty darn good in the real world. Sometimes your correlation coefficient will be very, very low and you can't really determine anything from that. Yeah, but even 0.5 is surprisingly good a lot of times. There's not a crystal clear answer like 72 and above on your correlation coefficient is correlated, right? Does it make sense that there's not, it might not be fun to acknowledge, but does it make sense that there's not a canonical answer to your question there, Jules?
It does. I guess I just want to make sure that, like, if we say that there's a correlation that you're, you know, if you have a certain threshold that you want us to meet and it doesn't show that, that's not going to be something that is detrimental to us grade wise.
Worry less about the grade part and worry more about your ability to handle ambiguity and your ability to communicate what you did find to stakeholders. We will talk about how much faith to put into your understanding of relationships later. Not yet, not on the storytelling. I just want to have you do some subgroups, do some descriptive stats, plot some stuff. But when we're talking about, okay, we have a correlation between an X and Y, how much faith should we put into that? We'll talk about that in the stats module, Jules, more specifically. So not so much like, we will hand you the rubric to this project so you know where the points will be counted. But you don't get a rubric in the real world. You get what's reasonable and what's not reasonable in the real world, right? Cool. All right, so let's talk about how to get to know our data at a high level. We could print out the first few records. And what I've done here is I've done a transposition because there's so many columns, they don't fit horizontally on my screen. That's why I did a .t. I chose to do a transpose since there were too many columns to show at once. And there's still too many columns to show at once. And we're certainly not going to get into every one of these, right? But take a peek at the first few records. Also, check your data source for a data dictionary. In our case, this data set is coming from something called the IBM HR Analytics Attrition data set. And so our explanation will be on there. And what else do we want to do? We want to check the value counts or a histogram. All a histogram is a bar chart of the value counts of the frequencies of your target variable. And then we might want to look for, determine if there's any work to do on data types or processing and cleaning the data before handling data types. And then check for nulls and handle them. And that's a larger process. We'll discuss that a little later. We can't do everything at once. So we've got a bunch of cool fields. We've got a bunch of different educational fields, employee number, job satisfaction, etc. So what I would encourage us to do is remember at this stage, our target variable is attrition. So let's get a value counts. Yeah. Check for nulls and handle them. Yeah. Easiest thing to do is drop rows that have nulls. That's the easiest thing to do, but you might lose a bunch of data that way. We can fill nulls with other values like averages, but then that overweights the average. So it's a trade-off game. For now, just drop rows if they have a bunch of nulls in them. So let's take a look at a value count or a histogram of our target variable. So our target variable was attrition, right? So we could do df.attrition.hist. Now built into into pandas, you can get a histogram. And look at that. It looks like most people stay, some people go, right? But let's show the numbers. So that would be df attrition.value counts. And now this is interesting. What's the rate of attrition? Or what's the proportion? Yes versus no. Well, little arithmetic, you could do the df where attrition is yes, get that shape as a proportion out of everything. Remember, shape bracket 0 gives you the number of rows. So we have a 16% attrition, give or take, for this data set. Now this begs the question, okay, what's the industry attrition? Now we don't know the industry that this data set is in, but we can say, what's a healthy attrition rate for a large company? Lower than 10%. So Houston, we have an attrition problem. If you look up customer churn rates for internet service providers, you can get the industry churn rate of customers, right? And so, well, yeah. Turnover rate should be lower than 10%. Okay, so maybe we source this. We say, oh, what have we found so far? So if the attrition is 10%, we're 60%, we're pushing 60% above that. So this is time to write takeaways. Takeaway, this company has 60% more attrition than what's considered healthy. Good. So that's a problem, right? Now, if we were to calculate this out and say, hey, HR, here's the dollar amount of this problem. If we did a little research to discover that replacing an employee takes between 50% of their salary on top of paying that original salary, 50 to 200%. Every little bit above the industry standard is going to hurt. Even any little bit below is going to hurt quite a bit. So we do have an attrition problem. That's our takeaway so far, right? Some other things we could do at this stage. We could check df info and look for nulls and run df.info or whatever you got to do to check for nulls and data types. Okay, so all of these objects should be strings. When we look at monthly income, that's a number. monthly rate, that's a number. I don't see any nulls here. And I don't see any objects, any strings that represent a numeric column. So that's good. We don't have to clean anything. So nice to know. Our data types, check out, and we don't have any nulls to worry about that we're aware of. We may discover something missing later, maybe an empty string somewhere. Now here's a fun one. I'm not really diving in super deep yet, but assume or we can quantify the cost of our lost employees or lost customers, since y'all are working on telco, right? So quantify the cost of our lost employees. What does attrition cost for companies? I think I did a search earlier and found 6 to 9 months salary on average. That's not great. So that's about half the salary to 75% of the salary. Okay, so cite your source and say, let's assume a 60% of salary to replace employees. Now, quantify the cost of our lost employees, DF, where df.attrition is yes, this produces a subset. This is why the subsetting stuff is so dang important, right? That's why we tested on it. Because you can't do stats unless you make subsets. Can't compare a group to the population unless you can make groups. Can't compare groups to groups unless you can compare groups, right? So let's look at our attrition people and let's see, years with current manager, standard hours. I did have a monthly in here. It's okay to go back to things. Hourly rate, monthly income. Okay. Dot monthly income. And this is going to give us numerics, right? Now, I don't know if these are dollars or if these are yen or what. We could sum everything up. So that's the monthly income of people who left. And if we have to multiply this by 12 to get yearly income, we will. That gives us yearly income. And then we can multiply that by the 0.6 that the People Keep blog told us about 50 to 75% of the salary to replace them. A lot of money. So sure, the business is, if we were to say, okay, business saves money if people leave, but that's assuming we don't need those individuals to keep production going, right? So we might have savings, but 1, 2, 3, 1, 2, 3, yeah. So versus keeping these people, it's costing us $8 million to replace all of these folks that are leaving. That's a lot more than what it costs just to pay those people, right? Break it down to what's important. And in your final figures, don't show 0.19 repeating in your final slides, just round that to the nearest dollar, right? If you're talking about $8 million out the door, don't count the cents, right? 8M, 8.1M. Pretty wild, huh? Cool. Let's see, what else can we do in step number 2? We've gotten to know the data a little bit. I'm not going to dive super deep into every single column. We don't need to talk to anybody in HR or accounting or anything like that. We don't have any nulls. The distribution looks like most people stayed, but the people who are going, there's probably something going on. So now is the part of the episode where we've quantified, we've articulated the problem, we've quantified the cost of the problem. Because if people had stayed, we wouldn't have to spend another $8 million replacing them. So let's add this to a little takeaway. Always write your stuff down. Takeaways so far. Attrition is 60% above a healthy level of 10%. Now, we don't know the industry of this data set, but if we did, the industry may have a different churn rate. Life insurance salesmen, higher churn rate than like high school teachers, right? Attrition is 60% above a healthy level. It may cost at least 8 million to replace. And we can just count, right? We can say DF attrition equals yes. We can count the number of yeses here and sum them up. How many people left? 237 people to replace 237 employees who left. So yes, HR, we have a problem. We're going to look into this. Give us a week or two and we'll get back to you with some of the drivers. Now, as a part of the episode, we're going to move into step 3. And step 3 is where we really start trying to answer our initial hypotheses, write down our takeaways as we go. If we were doing any ML, we would split our data and only explore train instead of the entire data set at this stage. If that's not immediately clear why we would do that, wait till we get into ML and we're going to drill it in, right? Step 3 is when we're exploring the data set, means understanding and interrogating the relationships between variables and the target. And this stage means use descriptive stats for now, just means, medians, averages, whatever. Visuals, and then hypothesis tests. Now I'm going to put a pin, I'm going to put an asterisk and say we'll get into hypothesis testing later. Right? For right now, just visuals and descriptive stats. All right. So what are some of the tools at your disposal, regardless of if you're in Python, a spreadsheet, anything else, we can visualize income to average income. Average monthly income is our actual to attrition. We can visualize those job satisfaction numbers to attrition. Right, we can break this out a whole bunch. Sometimes a few stats tell the story. Other times we need a handful of charts and visuals. So my thought process here is, what if I wanted to make a nice little bar plot? Bar plots show an average. Bar plots show average. And we can specify categories. So check this out. We can say across the x-axis, give me whether if or not there was attrition. And across the y-axis, maybe we want to look at that monthly income. All one word, monthly income. And then our data set is going to be our data frame here. What are you writing down in your notebook? Tell me. Dígame.
Anyone that makes, well, there's a higher rate of people that are making less than $5,000 a month that are quitting.
Yeah, it looks like the people that are leaving have, on average, a lower average monthly income. Yeah, this is, so we're starting to look at the target variable through the lens of another explanatory variable, in this case, monthly income, right? And that's a nice little 2-variable outcome. We could also look at the distributions. So bar plots give us the average. If we wanted to see something a little more interesting, the box plot, I'll do the X value as attrition, and then the Y value as, let's take a look at monthly income to get a little more information about it. So what box plots show us, box plots show the median in the middle of the box. And the median is one way of measuring the central tendency. The lower bound of the box is the first quartile. Upper bound of the box is the third quartile. So that's, I mean, that's pretty evident whether if we're looking at the averages or the distributions here. It looks like the people who are leaving the company weren't being compensated. There may be other reasons why, right? Maybe this had to do with, in the exploration process, you may cause yourself to start wondering other questions. So that's why we have to try and at least stay kind of on target here, right? So let's see, what can we do with this? Well, start listing your takeaways. Listing takeaways so far. Average and median and most incomes for folks who left are lower than folks who stayed. Management may not want to hear that, but it's the real answer so far. And there may be other reasons why. So we can keep adding to your takeaways. As you build your takeaways, write them down, right? Right now we're looking at 2 variables at a time. And bar plots show the averages, box plots show a distribution, and you can see some of the outliers. Let's see, what else could we do here? We could look at, yeah, we sure can. Now, do you want to look at marital status and monthly income, or do you want to focus on the target variable as well? Okay. Let's see. So let's break out, does marital status have anything to do with attrition? Now, these are both, attrition is a yes, no, marital status is another category. So we can't exactly plot a bunch of X's and Y's with these two things, right? But we could do, if we could answer these questions visually or with descriptive stats. We could say lost would be DF, where DF attrition is yes. We're going to make subsets, kept. So we lost some employees, we kept some employees. I'm going to make a couple of subgroups here. And then we can ask, of the folks who we lost, of their marital status, let's get the histogram. Take a peek at that. Of the folks we kept, let's take a look at marital status. and take a look at that. Well, those look pretty similar, like the gross number of counts are different because more people stayed than left. But comparing the shape, like the delta, the difference here.
The X values changed.
Yeah, the X values changed because we have more people who we kept, right? Now I'm looking at the difference between single and divorced here on the people we kept. On the single and divorced on the folks who left. Oh, that's very interesting. What's that? Oh, it's jacked up. Cool. Now that's very interesting. Yeah, because this sorted the values, a lot more married people stayed percentage-wise of the folks who left. And you could do other charts on this instead of just histograms. You do pie charts if you want to do a pie chart, whatever. Oh, that's very interesting. So it looks like single people are churning, are leaving the company at a higher rate than married people are. It's very interesting. So we add that to our takeaways. Right? Always document your stuff. So marital. So of folks who left, we have a larger proportion. Really all we're doing right now is comparing proportions of groups, subgroups with subgroups. We have a larger proportion of married folks. Of the folks, excuse me, we have a larger proportion of single folks. Of the folks who stayed with the company, we have a larger proportion of married folks or married employees. So like if the company, if the individual employee happens to be married and their average income happens to be higher than the folks who left, they're probably sticking around. Now, does this mean HR needs to try and make matchmakers and get everybody married who's single to keep them with the company? That could be a recommendation. You never know. Some companies get, they build themselves around culture, right? That could be their culture. Who knows? Kind of weird.
Free match accounts for everyone.
I'm sorry?
Like free match accounts for everyone.
Yeah. Yeah. What about gender? Yeah, this kind of curiosity. Let's take a peek at the gender. Okay, so we have, let's keep on asking questions. What's the relationship between gender and attrition? And we already built the lost and kept columns, right? So we can say of the folks who we kept with the company, taking a look at the gender, let's just do value counts instead of a visual. Okay, 730 male to 500 female. All right. What about the folks who we lost? Now, if we don't need to eyeball this, we could say, let's see, 501 to 732. And this is proportion of women employees staying. Okay, so 40%. And what if we were to do 87 out of lost? Interesting. Those are pretty close, right? Proportion of women employees leaving. Now we're going to have to slice and dice a bunch of these subgroups here because we can't visualize 9 variables on the same chart, right? It's just, we can't wrap our eyeballs around it. It looks like the story. Yeah, it looks like the story here is that gender might not be a great driver, but marital status seem to be. That's really interesting, and income seem to be. And we can look at 100 other relationships between these, quite literally, between these variables, right?
Do like pair plots and like try to see kind of what you see on a bigger scale.
Yeah, no, pair plots are interesting. So let's talk about pair plots. Pair plots are very valuable when we have numeric information, and we don't have too many pure numerics. We have some ordinal information. I mean, you can do a SNS.pair plot on the data frame. We can do that all day long. Not all of these pair plots are going to be fruitful. Yeah, and I say that because if we pair plot things that are ordinal, like 1, 2, 3, we'll start getting into like almost like columns of data points. And pair plot takes a long time, even on a small data set, because it's plotting out everything, every single data point. It's a good place to start. I like to think of pair plot as casting a very wide net for our numeric columns. And then if a single or if specific plots seem valuable or interesting, we'll make a rel plot or a scatter plot or something like that for those variables. And if we have columns that are rankings like 1, 2, 3, 4, we might do better to treat those as categories. Yeah. Yeah, Jason, question?
Categories have the highest variance in relation to the attrition.
When you say variance, do you mean like the calculation of variance or like the VAR function?
Like for all the people that said yes or something no, just like compare the two, it's like all the different, I guess, see like which ones have like the highest variance.
Yeah. Get descriptive stats and visualize. Yeah. Pair plot is going to approximate that, but there's not a magic button that says do all the analysis for me. There's some tools like Power BI and Tableau have some tools that like automatically do stuff, but you can't always trust them. And this is why pair plot is a mess, right? Yeah. So pair plot is nice if you have like 5 variables. Yeah. So yeah, just because you can doesn't mean that you should, is my punchline. And I'm going to add this to the notes. Use pair plot sparingly if you have many columns, or reduce your columns to make a more clear visual. Yeah, I had a question from Jen. Go ahead, Jen.
I was wondering if we can move on to testing another thing.
Yeah, yeah, what's on your mind? Yeah.
Is it possible to never be advisable to eliminate things like straight other data for you, just hide things or so if they come perhaps the most your hypothesis something around that?
Oh yeah, yeah, absolutely.
For some of those in-class questions, can you repeat what's being said a little bit so we know what you're now looking at?
Yeah, absolutely, Kate. The question was, can we do a pair plot on this on a smaller list of variables? And the answer is yes. So here's another example of why pair plot is not always a magic tool. I have two ordinal columns, relationship satisfaction and job satisfaction, and then monthly income. But see how, because one axis is on discrete numbers, this doesn't mean anything to us, right? Now, something that discrete numbers or ordinal numbers can often look like unfulfilling. They don't even tell the story. Often don't visually tell the story, right? So use pair plot sparingly. I don't have a lot of other continuous values. I have age, right? And it's kind of all over the place, right?
What was the last one you had?
Relationship satisfaction and job satisfaction. And those were kind of gross looking. Yeah. So just because you can doesn't mean you should. Yeah. And we can do, yeah, like Kate's putting in the chat here, we could do a hued cat plot. I love me some cat plots, and I love the hue argument because you can add extra dimensionality. I'll give you an example. We did a box plot earlier. Let's see, let me double check. Seaborn box plot. Yeah. So box plots are pretty cool. We could use hue argument to add another dimension to our data. So this monthly income and attrition, what if we used hue or even, this is not supporting call, but we could do hue on another binary or another category of some kind. And we could say here, that marital status. And we'd have to move that legend. But now we're seeing, yeah, the green divorced is, and the single, the people who that's very interesting, yeah. On balance, regardless of marital status, people who stayed are making more. Go figure. And then look at the median income on divorce, the folks who left, the median is so low, it's almost to the lowest quartile, the first quartile. Yeah, Jen, you had a question. You wanted to move forward with another question. What's on your mind? Yeah.
I was thinking if we go back up the attrition of the maybe adding in something like
Yeah. Y could be, I think that's the name of the column. Years in current role. Studley case here. And we could set the data to be the data frame. Let's see what that looks like. Well, that's kind of all over the place. But what if we were to break this out by, say, column could be attrition? Because notice we didn't add attrition into this rel plot. Interestingly, it looks like the folks who stayed have been at their roles longer. Yeah, that's an interesting takeaway. That's something worth writing down. We can add new takeaways and try to collect them all in one place so they're not all over your notebook. But our new takeaways, folks who stayed have been at the role longer than folks who left. And also we see the income here too, to the right on the x-axis.
very few, like, the incomes.
Oh, like made bins for the income?
Yeah, if you do, so everything, at least like from the right side, it's like the top of the right, it's very. Incomes kind of. So.
Yeah, I mean, this visually is selling the story that the folks who stayed are making higher incomes. Now, the interesting part about this rel plot, every single data point on a rel plot represents a row, represents an individual, as opposed to things like box plots, which are showing aggregates. So this data point right up here is Jane, who's been with the company super long and is making a lot every month. And then the plot next to Jane is Bob. So those are individual rows in the database. Yeah, I see some hands up remotely. I didn't catch the order.
Kate had her hand up first.
Lies, but I'll say it anyway.
Okay.
So is there a better representation of this? Because I feel like you can't really make out the quantity per Y value. You know what I mean? So it may look like the tenure is greater on the right-hand side, but in reality, we have 6 times as many data points on the right-hand side. So is there like a chart you'd recommend for reviewing that?
We could take, we might be able to make it like a bar plot and look at averages. And look at, if we wanted to break out by, and this is going to show a lot of junk, years in current role, and then Y could be, actually, let's just keep it simple. When in doubt, keep it simple. Attrition on the X, and then on the Y, let's do years in current role. And with bar plot shows averages. Yeah, now we're not seeing all that visual noise of those individual data points. And what about the distribution? Box plot shows distribution, spread. It'd help if I change the code to box plot. Yeah. I'm sorry? They're outliers. So zooming in on what a box plot is, the line through the middle is the median. The line at the bottom of the box is the first quartile. So the median is your ordinal halfway point of sorted data, right? Your first quartile is the middle of the data in order between the lowest value and the median. That's what the first quartile is. Then the third quartile is the top of the box. Most of your values live between the first quartile and the third quartile. But these little whiskers out here are something called the interquartile range rule, where you take a constant, usually 1.5 or 3, and multiply that by Q3 minus Q1 to get that range. That gives you these little fences. So anything outside of that fence is considered an outlier according to the interquartile range rule. That's not your number one way of finding outliers everywhere, but it's good when you don't have a better tool. Can I share my? Yeah. And V, I see you have a question, patiently.
So this, the outcome seems pretty intuitive, that the people that didn't quit the job are the ones that stayed in it longer. And that seems like a very intuitive sentence that makes sense. And in the industry, I've heard a lot of terms as actionable data. So this doesn't seem that you can really do much about it.
Yeah, because staying is a function of not churning, right?
Yes.
How about this one? How about we change this up just a little bit? And we have a column called years since last promotion. Here's a thought. So the folks who stay aren't getting quick promotions necessarily. There's a little bit of a difference here, right? Now, I'd say that our chart showing the monthly income disparity and what we discovered with marital status, I think these are actionable. Now, marital status is a protected class. You can't just tell your recruiters to go and hire married people. That's against the law, right? But what's not against the law is paying people more to stay. Right? This one's simple. And we can break things out. Yeah, we can keep slicing and dicing and breaking things out even further. In the interest of time, I'm not going to give this data set the full treatment, right? Because we're going to come on lunchtime, we're going to take lunch, and then in the afternoon, what I want y'all to start doing is we're going to have Tableau lessons tomorrow. Tableau's a great tool. Instead of writing Python code, you click and drag stuff. It does a lot of really cool stuff. But what we want to do this afternoon is start planning this project, basically have a soft project kickoff and start asking your planning questions, start getting to know your data set, get your hands on the data dictionary, etc. Fred, question?
Ryan, what's a good rule of thumb when you're doing your data exploration? You say, hey, I want to get more information on data set, but I gotta stop at some time.
Yeah, at this stage, if I had to deliver a report by noon or by lunchtime, the biggest bang for the buck that I see is the marital status, but protected class, we can't target based on that. Bert had a suggestion, free match.com accounts to employees, right? That's not illegal. That would get a little weird once the employees start seeing each other on the site though, right? But the monthly income, I think it would be a big one. That's a big, huge takeaway that we could take. If I'm on the elevator with a VP and it's like, hey, I'm sorry, I can't make your presentation this afternoon. I got to catch a flight. What's the big deal? And I said, people who are leaving on average are paid significantly less than the people who stay. Now, what that executive chooses to do with that information is up to them. But yeah, to Fred's question, how do you know when you're done? You can just keep digging and digging and digging and digging, right? It's a lot of fun. And if depending on how many pairs or combinations of 2, 3, even 4 variables, I mean, you could spend days, weeks analyzing just this one data set. I mean, you could spend 2 weeks just on telco, but go focus on the bang for the buck rather than counting the toenails on an ant.
Like a 1/3, 2/3 rule, like you say, add like you know, 1/3 of my time I'm cleaning and trying to organize the data set, 2/3 like make sure my analysis.
Right. Let's say your data is squeaky clean already, which it's not. But if it was, try to put the lion's share of your time into exploring. And then the second largest chunk of time into creating your presentation. If it's a presentation, slide deck, yada, 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 put your time into making that story look great. Like everything that Adam's been sharing with you is my guidance. So sometimes you cannot move forward with analysis until you clean all the data, handle all the nulls. But looking at these different columns, if I had to clean a bunch of things, like if we looked at the value counts of everything individually, we would discover everybody is over 18. Nobody has overtime. We might discover other things, right? Or the number of hours worked, everybody's working the same number of hours per pay period. So you can just ignore stuff. But generally, if it would be, oh man, I got to spend 2 days cleaning everything, those are where your initial hypotheses come in on what columns to clean first. Because a super squeaky clean data set for every single thing is not going to get you there if you need something by tomorrow, right? So sometimes you might clean up a column before you analyze that one column, and then it saves you from having to dive into everything. Yeah. And this is just the tip of the iceberg. I've shown you some aggregation charts like box plots and bar plots that show averages of the distribution. This data set doesn't have a lot of continuous numerical data. It's got age and income, but that just kind of looked like a fan. So you're probably going to use a lot of cat plots on something like this. Similarly to telco. Telco doesn't have too many numeric columns. It's got tenure in months. It's got monthly charges, total charges. Well, monthly and charges and total charges are a function of each other linearly, right? As a function of the number of months. And everything else is category. So you're probably going to lean into your categorical plots, breaking things out by hue, breaking things out by column, perhaps. Yeah. So yeah, like V pointed out, yeah, folks who stayed long, folks who have been there longer tend to have stayed. Sometimes you see a self-evident, the snake eats its own tail kind of a takeaway. That shouldn't be earth-shattering. Just like, hey, VP of operations or whatever the role is, the people who are leaving are being paid less. I mean, what can they do with that? Well, if you quantify because that's common wisdom, but if you quantify the problem, okay, of the people who left, of the 237 people who left, the approximate cost of replacing them and training and everything to hire is $8 million. Do you have $8 million extra in the budget to chase this problem? No? Okay, give me another week to analyze this. Sometimes your takeaway might be, here's something interesting and I need more time. You're always going to want more time, but you're never going to get it. Sometimes you get it. Cool. And then, yeah, we'll leave the rest of step 3 is comparing groups to the population, comparing your subgroups to other subgroups, and start with the big stuff. Start with the binary. Start with your target variable. Start with your target variable in the most impactful appearing columns. If you have a little more time, you might dig into the self-reported numbers, those survey figures, the job satisfaction, the relationship satisfaction, et cetera. Cool. We went on this little aside because we've noticed in some past classes that we went right into the storytelling project and folks didn't know how to find the story of the data. So I wanted to make sure that y'all knew how to find your story in the data. And then in the afternoon, we'll kick off the project and get a little work in, at least a little planning. And then we will have some more storytelling and Tableau content after that.